Hello, I'm Jamie Ellis from the University of Florida's Honeybee Research and Extension Lab. In this episode of a video field guide to beekeeping, we'll be discussing Varroa mites, the #1 killer of honeybees on the planet. Varroa mites are ectoparasites of honeybees, which simply means that they live on the outside of a honeybee. Varroa mites are actually quite small to the naked eye, but compared to their host, they're one of the largest parasites on the planet. It would be like you or I carrying a basketball-sized tick on our body. Varroa mites are not natural pests of Apis mellifera, which is the honeybee that we keep here in the United States. Rather, they're a natural parasite on Apis cerana, an Asian species of honeybee. In 1987, Varroa mites were discovered in the United States, and since that time, they've spread all over the United States. In fact, Varroa mites are not only found in the U.S., but they're found in most countries around the world. They remain the #1 killer of honeybees globally. The behavior and biology of Varroa mites is actually well understood. Varroa mite females are the only ones that you will find outside of brood cells, and you'll find them actually attached to adult honeybees. Varroa mites actually feed on the hemolymph of the blood of the bee. Now, bees are made up of many hard plates or segments on their body. Varroa mites can't penetrate these plates to actually get to the bee hemolymph. Rather, they have to go to the creases or the crevices where these plates meet. They'll insert their mouth parts into this soft tissue and suck bee hemolymph. Once Varroa mites are ready to reproduce, they will crawl off of adult bees and go into brood cells. Now, the age of the brood cell that they are targeting happens to be larvae that are just about to be capped. When larvae are ready to be capped, they produce a pheromone that tells the worker bees in the colony to cap over the cell with a waxy capping. Varroa mites can cue into that, and then they can go into the brood cells prior to the cells being capped. When Varroa mite females do this, they crawl to the very bottom of the brood cell where the royal jelly is. They'll crawl into the royal jelly, and they have a special apparatus on their body that they stick out of that royal jelly that permits them to breathe while they're hiding under the bee larva. Once the larva is covered over with that waxy capping, the Varroa mite comes out of the brood cell, out of the royal jelly, attaches itself to the larva and begins feeding. At this point, she will oviposit, and the first egg that she lays is actually a male Varroa mite. Subsequent eggs are females. So Varroa mites, it's perfectly normal for brothers and sisters to mate inside the cell. Varroa mite males never leave the cell. Varroa mites are mites, so they don't go through egg, larva, pupa, adults like most insects do. Rather, they have nymph and deutonymph stages. So as they're maturing in the cell, they're actually white until they get to their later developmental stages when they begin to harden. Male Varroa mites are always white. They never get to the stage where they harden. Once the bee is born or chews its way out of that cell, it will come out with any mature Varroa mite female offspring. As she comes out of that cell and she comes into contact with other bees, the Varroa mites might jump from bee to bee and continue feeding or go into another cell to reproduce. What's important to note is that if enough Varroa mite foundresses or females who go into the brood cells at the beginning go in there, then you can actually have larva death or pupal death. The bees will never be born in the first place. Another problem with Varroa mites is when the mites are in the cells, they can actually give our developing bees various viruses. One virus in particular, deformed wing virus, causes the bee's wings to be deformed. So as the bee is born and chews out of its cell and emerges, you'll notice one of the symptoms of Varroa mites is you'll have deformed wings in bee colonies. And this is caused strictly by the deformed wing virus that the Varroa mite transmitted to the adult bee. Varroa populations explode quickly in spring and summer. In fact, they very closely mimic natural honeybee population growth. Varroa populations are very low in fall and winter, and as bee populations grow in spring, Varroa populations closely follow. Bee populations naturally decline toward the end of summer, but Varroa populations are peaking at that point. Consequently, that tends to be the time of year when Varroa problems are at their worst. Bee populations are shrinking, Varroa populations are growing, and you have a perfect storm of Varroa mites take over the colony. Symptomology associated with Varroa mite presence in bee colonies is fairly clear-cut. Dead bees. There's really no better way to put it. Colonies were ordinarily strong, they weaken very quickly, and all of a sudden you have dead colony. It's very interesting. Varroa mites are able to kill colonies rather quickly, and in fact, populations will shrink quickly, and then all of a sudden you'll have no bees. You'll have some brood left behind, you'll have honey and pollen, etc., but there'll be no bees in the colony. Another symptom that tells you that you possibly have a Varroa problem is you have a lot of bees with deformed wings. Remember, we talked about Varroa mites giving our developing bees deformed wing virus. If you see large numbers of bees, greater than 10 to 20% of your bee population having deformed wings, that is a true symptom that you have a Varroa mite infestation in the colony. Segueing straight into diagnosis, the two go hand in hand. If you're having Varroa mite problems, you'll actually see Varroa mites. Varroa mites are small, but they are possible to see with the naked eye. Oftentimes they'll be found on the bee's thorax or abdomen, but particularly between the plates of the bee's body. Furthermore, you might find Varroa mites in the brood cells of bee colonies. The best way to look for Varroa mites in brood cells is to use a capping scratcher. Now you know capping scratchers is that tool that you use to remove the cappings from frames of honey that you're about to extract. Well, in this case, you can use the capping scratcher to look for Varroa mites in the cells of bee colonies. How you do that is you take the points of the capping scratcher and slowly insert them under the capping of the brood cell. With a very quick hand movement, twisting the wrist, pull your capping scratcher away from the frame. What this does is this causes the points of the capping scratcher to catch the developing bees under their head and remove them from the cells. Then you'll simply be able to look at the developing bee's body for the presence of Varroa mites on those bees. Another good way to diagnose Varroa problems is by using sticky screens. In fact, in my opinion, this is the best way to diagnose Varroa in your bee colony. Sticky screens are very simple. They're simply wooden frames with wire 8-mesh screen across the top. What you'll do is you'll fasten sticky cardboard substance on the bottom of the sticky screen with the sticky side pointing up towards the screen. You will then slide the sticky screen into the bee colony's entrance and leave it there for 3 days, screen side up. Now what happens during this 3 days are Varroa mites just periodically fall off adult bees as bees are grooming. Varroa mites will fall off the bees through the screen and contact the sticky cardboard or sticky paper on the bottom of the screen. It will stick them there and permit you 3 days later to remove the screen and actually count the mites. The reason I tell you to leave it in for 3 days is that gives you a better sample of the Varroa population in the colony. Varroa mite fall is dependent on weather, humidity, sunlight, wind, etc. So it's best to leave it in for 3 days to give you a good assortment, a good average of temperature and weather extremes so that you'll be able to normalize or standardize Varroa mite fall. Also good to have on sticky screens is a strip of cloth on one end which permits you to remove the sticky screen rather easily from the colony. What you're looking for in this particular instance are Varroa mites on the screen. Now most interesting here is you could actually correlate the number of Varroa mites on the sticky screen with the number of Varroa mites in the colony. If you have greater than 60 or more Varroa mites on your screen per day, so that's 180 Varroa mites after 3 days, then you have 3,000 or more Varroa mites in your colony. There are other good ways to diagnose Varroa problems in your colonies. Both of them are very similar. The first is the ether roll. The ether roll is the more traditional of the two, and it's simply where you put about 300 adult bees, or about 1.5 inches of adult bees, into a quart mason jar. You'll then spray ether starter fluid in there with the adult bees. Now the unfortunate thing about this diagnostic tool is that it kills the bees. What you do is you'll put the top back on the jar, you'll shake the jar for about 30 seconds. Following this, you'll slowly turn the jar and count the number of varroa mites that are stuck on the inside wall of the jar. The fortunate thing about ether rolls is, like sticky screens, you can also estimate the number of varroa mites in your colony based on the number of mites in the jar. 17 or more varroa mites in the jar equals roughly 3,000 or more varroa mites in the colony. The third and final way to get a fairly accurate diagnosis of varroa levels in your colony is to use a powdered sugar shake. Now it's very similar to the ether roll in that you try to get about 300 bees in your jar, which is about 1.5 inches of bees. But this time, rather than spraying engine starter fluid in there on the bees, you put about a tablespoon or two of powdered sugar in there with the bees. You replace the jar lid, but this time, rather than the jar lid having its solid piece, the jar lid has 8 mesh screen. So what you do is you slowly shake the jar, then you leave it alone for about 2 to 5 minutes. As the bees are moving around in this jar, the varroa mites become dislodged from the bee. Then you'll turn the jar over and slowly shake it. Because you've got screen mesh on the end of the jar, varroa mites will come through the screen. Now if you shake this onto a white surface, it'll be easy to see and count the varroa mites. Varroa control is best approached holistically using integrated pest management. Now remember, integrated pest management is resting on the foundation of an economic threshold. That is the pest level above which your colonies are in danger of reaching the economic injury level. Put in plainman's English, that simply means when varroa mites hit the economic threshold, it's time to use chemicals. Otherwise, they're going to cause some significant problems for your bee colonies. So the goal of integrated pest management is to use a number of different non-chemical control approaches to suppress varroa mite populations so that you may eliminate altogether, but certainly postpone the need to use synthetic pesticides. So let's discuss some of those non-chemical control approaches. Largely integrated pest management, the control approaches that go within it can be broken down into a number of categories. But with regard to varroa mites, there are 2 main categories that you can use. The first being cultural mechanical control, the second being genetic control. Let's talk about cultural mechanical control first. Cultural mechanical control of varroa mites is simply a change in practice, something that you do different, maybe a hive modification, maybe a behavior modification, whatever, but ultimately it results in reduced varroa populations. There happens to be a hive modification that if you use it, you can reduce your varroa populations by 15%. What is that modification? Screened bottom boards. Now if you know the typical bottom board on a honeybee colony is a solid piece of wood, if you simply replace that bottom board with a screened bottom board, which is simply no solid piece of wood, but rather 8 mesh screen in its place, you can achieve 15% reduction in varroa populations. How does it happen? No one's sure, but there are some theories out there that as bees groom themselves, varroa mites fall off the bees, fall through the bottom board. Now if it was a solid bottom board, the mite would hit the solid wood, would quest, wait for a bee to come by and get on the bee and go back into the colony. But with screen bottom boards, varroa mites fall through the bottom to the ground, never to cause a problem again. A second cultural mechanical control lies in drone brood trapping. Now if you remember our discussion earlier, I told you that drone brood is more attractive to varroa mites than is worker brood. Now using this against the varroa mite, you can actually purchase drone brood foundation. If you put that in your colonies, the bees will pull out drone cells on that drone brood foundation. Now the queen will go in and lay drone eggs or unfertilized eggs, which will result in drone larvae and drone pupa. Now remember, varroa mites prefer to go into drone cells. So if one of your frames in your colony has drone foundation, then varroa mites are preferentially going to be drawn to that comb as the drones are developing. The moment that comb is capped over, the moment the larvae are capped over, you can remove that comb from the colony, freeze it, and reintroduce it to the colony 24 hours later. The bees are dead in that frame, the mites are dead in that frame. The bees in the colony will then remove those drone pupae and the process starts again. Obviously, this is a very labor-intensive way to reduce Varroa populations, but on a small scale, hobbyist or sideliner beekeepers, it's very applicable. It's really good at lowering Varroa mite populations. Now that's cultural mechanical control in a nutshell. Perhaps the best way to control Varroa mites without chemicals is to use genetic control. Now there are at least 3 different types of honeybees that have been bred for resistance to Varroa mites. The first is the Minnesota hygienic queen. The second are Russian queens. The third is the VSH queen. Let's talk about Minnesota hygienics because they've been around the longest. Minnesota hygienic queens are bred for a very specific behavior, hygienic behavior. Now, hygienic behavior is where worker bees in the colony can detect the presence of Varroa mites in the brood cells. They uncap those cells, they remove the developing bee, which brings out the Varroa mites. Bees that do this really well reduce Varroa populations in the colony. VSH queens, or Varroa sensitive hygiene queens, is actually a different type of queen, but it's based on the same principle. It's basically bees that are, quote, super hygienic. What really happens in a VSH queen, or at least what people think happens, is honeybees can detect the presence of Varroa mites in brood cells. We've discussed that. But with VSH queens, they can selectively remove only those brood cells that have reproducing Varroa mites, which means that the honeybee can tell if the mite under that cell capping is reproducing or not. If it's not reproducing, it's not a problem, so the bees don't put the energy into removing it. If it is reproducing, bees uncap the cell and abort the brood. The third queen I mentioned is the Russian queen. Now, Russian queens are a European race of bee that was taken over to Russia hundreds of years ago. And because Varroa mites are native to Asia, the Russian bee growing up in Russia was exposed to Varroa mites and over time developed natural resistance to it. It's been imported to the United States and provides very good control of Varroa mites. In fact, using these various types of queens, you can reduce your Varroa populations 40 to 50% in your bee colonies in the best case scenario. So I strongly recommend that you use resistant stock. Now, if you're using resistant stock and coupling it with screen bottom boards, you may reduce your Varroa populations 50 to 60% at any given time. If you do that, you may keep your Varroa populations below the economic threshold. But in reality, there's no silver non-chemical control bullet. So as such, you can probably expect Varroa populations to reach the threshold ultimately, even if you're using resistant stock or screens. Now keep in mind, it may take longer for them to reach the threshold, but they probably ultimately will reach the threshold. Once they do, then you're permitted to use chemical insecticides or miticides to try to attack the Varroa mites. Now listen, I'll be completely honest with you. I do not like to put miticides or chemicals in my bee colonies. I do everything I can do to try to control Varroa mites and small hive beetles and all these other pests and diseases without using chemicals. But in the real world, integrated pest management is not perfect. So there may be a circumstance that demands that you intercede with Varroa mites using a chemical treatment. Now, there really are about 5 chemical treatments that you can use in your colonies against Varroa mite. The first 2 are Apistan and Checkmite Plus. Apistan was the first product that came on the market for use against Varroa mites. Apistan has the active ingredient fluvalinate. It's impregnated into a plastic strip, and the plastic strips are hung between frames and the bee colony. As bees walk by the plastic strip, the mites get exposed to the strip, therefore the chemical, and the mites die. Checkmite has the active ingredient Coumaphos, and it works on a very similar principle. Coumaphos is impregnated to a plastic strip. The plastic strip is hung between frames of the bee colony. The bees walk by the plastic strips, and the mites die. The good thing about these chemicals is when they worked, they really worked. They could get over 95% efficacy or control of Varroa mites. The bad thing about these chemicals is they've been misused. Because of that, Varroa mites have developed resistance, and I would even venture to say extreme resistance to Checkmite. and apistan. So I typically don't recommend the use of these two miticides in bee colonies. The second reason I don't recommend them is just now scientists are beginning to discover a number of sublethal effects of these chemicals on bees. So not only do they not really work well anymore, but they simply hurt our bees. So that's an important consideration. Moving on from those miticides, we come to a little bit more softer or natural miticides to be used in bee colonies. And they fall largely into three different mite names. The first is Apilife Var, V-A-R. Now Apilife Var is a vermiculite or wafer tablet that's impregnated with thymol, eucalyptol, menthol, and camphor. Now all of these are essential oils that plants produce. This tablet is broken up and put into bee colonies. Now the bees, as they're in there with those tablets, the tablets kill the Varroa mites. Now Apiguard, the fourth product that I'm mentioning, is very similar to Apilife in that it uses botanical, particularly thymol, as its active ingredient. But in Apiguard, thymol is impregnated into a gel. The gel is put into the bee colony, and as the bees are removing this gel, it gets on their bodies and it kills Varroa mites. The third product that I want to mention with regard to the softer products is formic acid. Now formic acid is a natural acid that you find in many places. Formic acid will come on pads that you put into bee colonies. In order to insert them correctly into bee colonies, they must be put on a wooden frame so that they don't touch the frames in the bee nest. Now anytime you use any of these 5 miticides, checkmite, apistan, formic acid, Apilife Var, or Apiguard, it is vital that you follow the label directions. You notice I have not given you any recommendations on how much to use, how often to use it. Neither have I given you directions on where to apply it in the colonies. And that's simply because labels change so frequently, and the label is the law. Rather than me giving you advice on how to use them, it's more important for you to know what products you have at your disposal, such that if your Varroa populations reach the economic threshold, you'll know what you can use. To be blatantly honest, a number of beekeepers don't use integrated pest management, but rather treat Varroa mites prophylactically or before you have the problem. Used to, we would recommend that people treat twice a year, in early spring and in fall. But now that we know that these chemicals can harm bees in various ways, it's best to use them only when you have problems. Now just one final word about integrated pest management. For Varroa mites in bee colonies, it's not a perfect science. For the average colony, in the average situation, it's about 3,000 mites per colony. But if for whatever reason your colony's weaker or stronger, or you're in the northern states or the southern states or a drought, etc., thresholds can fluctuate. So you're going to have to use these sampling tools that we've told you about, as well as some good common sense to determine if it's time for you to use these chemicals. Well, now that I've discussed with you a number of chemical and slightly less harsh controls for Varroa mites, let me talk to you a little bit about some of the other controls that are used. Now, there are a number of products registered for the control of Varroa mite that I didn't mention, and that's probably because their efficacy is not good enough, really, in my opinion, to warrant using in colonies. Secondly, there are some other things like small cell foundation that many beekeepers believe in, or dusting powdered sugar into your bee colonies to control Varroa mites. The only problem with some of these things like this is that they're good ideas in theory, but there's no good data to support their use or their efficacy against Varroa mites. So my recommendation is to follow the things that we know very much about, like drone brood trapping or bottom screens or resistant stock, rather than going off and using small cell foundation or powdered sugar, simply because we don't know enough about them. Without question, Varroa mites are the most vexing problem for beekeepers, not only in the United States, but in the rest of the world. If left unchecked, Varroa mites almost assuredly will kill your bee colony. That's why it's important to understand their biology, their behavior, and various control methods that you can use in order to get a handle on Varroa mites. Hopefully you've learned something in this episode that will help you be a better beekeeper, and control Varroa mites more efficiently. I thank you for watching a video field guide to beekeeping.